Hello everybody, this is a cam timer taken out of a Whirlpool washing machine. Pretty much every washing machine would have had one of these to control operation until like a few years ago when they started using electronics to do the same job. This is an electro-mechanical device. It's all mechanical, it's clockwork. Quite a simple concept really. Yeah, but there's nothing in this that can't be done using a programmable logic controller. You could probably even take one of these out of a washing machine and replace it with an Arduino doing the same job. The wiring would be complex, but could be done. But yeah, but this is something, this is a sort of technology that has worked well and served society well for hundreds of years, thousands of years in fact, since there's evidence to suggest that the Romans and the Greeks themselves, the ancient Romans and Greeks used similar sort of technology, so certainly nothing new. So yeah, it's a cam timer. So before I take it apart, I'll try and explain a little bit how it works. Say all mechanical. So inside here, there are a series of cams. Cams are just wheels with notches or pegs or lumps around the edges, which as they rotate, they press upon switches or buttons. In this case, you have something a bit like that. There's a timer motor behind, and that's this thing here that rotates this, and as it rolls around, it'll push up the switch here. And for example, in this little diagram here, if this goes up, press this button down and turn on this circuit. Very simple. Or in some cases you could have it going in two directions. You might even have something, instead of just having simple on and off, you might even have something dipping down like that there. So you could have potentially two positions on the switch, off, or three positions, off, up and down, and that might be useful for controlling motors, so you can have a motor switch direction. Outside of washing machines, cams are used a lot in industrial automation, and they would have been used like in animatronics at one point in time. So, a bit more detail about the whole timer cam operation. So within here, you would actually have several cams, and each one would be dedicated to controlling a certain part of the machine. So in this case, I've taken a very simplified method of operation. I've got these concentric, but in reality they're all the same size and they're all locked together, so as they all rotate in unison. So the first one is timer power. So this is this bit at the back. As you go around, the part of the timer will be cut, only to be restored by another component in the setup. So for example here, as soon as you turn on the machine and you twist the cam from the off position, so it's off there, you don't actually switch the timer on, you actually switch on the water solenoid. And the water solenoid opens the pump, and there's a sensor that detects when enough water is in, and when enough water is in, a relay arrangement, and it's probably a fairly complex relay arrangement, and as you can see there are some relays in here, Omron relays, which are really quite good quality. What voltage are they? They're 240 volt relays, but that'll do. I can find a use for them. So that'll switch on the timer relay, and as the timer moves across one notch, the cam on the water solenoid will drop down, but then the cam that controls the drum motor, the actual rotation of the drum, that'll switch on, and that'll go on until another part of the cycle. So typically, I don't know how many is going to be in here, but I'm going to imagine there's going to be 5 or 6. So one for the drum motor, one for the possibly two for the solenoid, because we have 2 water inlets, although modern machines only have 1. Interesting thing about the hot water inlet, if your washing machine does have 2 water inlets, a hot and a cold, it doesn't matter if hot water is coming through the cold, the washing machine will still heat it up. It's just like if you've got hot water, it helps the washing machine get there faster, to the required temperature. But yeah, so really simple technology, but it can be made really complicated by the application, just by adding lots of sub-circuits. For example, our machine has, which I haven't got it here, but this is our own machine, which lasted us about 20 years, which is impressive, all things considered. We had a separate board for controlling the spin cycle speed, so whenever the spin cam came on, it would send a signal off to send us current off to the set the subboard which controlled the spin cycle speed. Whereas cheaper machines wouldn't have that. You'd have one spin cycle speed or maybe two, depending on the way the cams have been set up. Yeah, so like I say, there's a lot of sub circuits as well, lots of sub relays. So, like for example, when it's needing a feedback, for example, when the water solenoid opens and it needs to know how much water's come in, there's a water sensor. It's just basically a rubber tube with a micro switch at the top, sitting beside the drum, and as water fills up, it sort of creates pressure in the tube, and once it reaches a certain pressure, a switch flips, and that can go through a series of relays to switch things on and off if need be. And you could actually combine relays into logic circuits like OR, XOR, and there is a lot of flexibility in what you can do with this. And another, for temperature, generally there's no feedback because there'll be a separate, they just use a simple thermostat. So as long as the water doesn't get too hot, they don't care. And so, like if, for example, if your washing machine's reaching the end of its life and the heating element is not as good as it used to be, you might not get up to the temperature you think you're getting. That might be a sign that your washing machine's on its last legs. That being said, modern detergents don't need lots of heat. In fact, for most everyday wear and tear and everyday dirt, 0 degrees with a modern laundry detergent is fine. That's perfectly fine. Cold water. Anyway, enough talking. Let's get this taken apart. Now, manufacturers generally don't like you taking these apart because, and with good reason. A lot of the time they don't like you doing it because they'd rather you sell you a new part. But with these, if you open it up and have a look around, you'll find that you'll get dirt into the cam mechanism, and because they're usually generally made of plastic, they'll start to fall apart. They not fall apart, but wear down as the grit gets in. It's worth noting also the number of inputs and outputs here. These all go off to various circuits within the washing machine, for example heaters, sensors and the like. So it's really quite a complicated setup. Yeah, this is going to take me a while. I might have to just take a skip on the video. Or maybe not. We'll see. Brittle. It's been 20 years old, so I'm not surprised that the plastic's getting brittle. Although, I'm going to have to clean all this up. Wow, that is really brittle. So what have we got here? A couple of relays, lots of resistors. It was manufactured by Invensys, which is a British engineering company, which was recently taken over by Schneider of France. They used to be called Seebay. I used to know Seabay back in the 80s, but they also owned Westinghouse Signals, so they make a lot of signalling systems. When I worked on the railways, I used to come into contact with them a lot. Now, what's that? That's a relay, a big chunky relay, and these are, the 24 volt to 240 volt relays. If I can get those off, I'd like those, because Omron relays are really quite good. There's a little subboard here. It looks like a PLC, really. Can I get this out? Nope, that's not coming out. Let's get this off the backboard. So after a bit of digging around and destruction, as you can see, I found out this is the ST72311, which is actually a timer chip, a reprogrammable timer chip. So it's with an EEPROM element to it. So it's not quite a microcontroller, or a programmable microcontroller. Generally, it sort of works on the basis that if it receives an input on one pin, it'll time a certain length of time and then send an output on another another output pin. So it's effectively it's a primitive PLC, really. That's what it is, programmable logic controller. So I would actually say that this whole setup here is kind of a hybrid, really. You've got the cam timer, which is purely mechanical, and you've got a more electronic version of it in the timer chip here, which like I say, it's primitive. It doesn't do calculations, it just simply waits for an input on one. Depending on what's in its EEPROM element, waits a certain length of time, sends a signal out on another chip. Oh, sorry, another pin. So if anything, it's a more sophisticated version of the 555 timer chip. So interesting. So I think we're getting into hybrid technology with this kind of controller. So I don't know, maybe they just didn't want to fully commit to a PLC at this time. Maybe they weren't reliable enough. Now I would actually think that with washing machines, PLCs might struggle a bit, given how they vibrate, shake around, and also like if you put on a boil wash, like the whole thing gets really, really hot. So then you have to sort of think about durability. How am I going to get into this? This looks like a challenge. Kind of harder to get into a politician's soul. Okay, there is a lot of plastic pins holding this down. Just nip away at them until I get in. I may jump on a bit. Oh, there we go. Oh, okay, so yeah, the timer. I just want to talk about that a bit. It's just basically a motor, but it's a very regular time. No, it's a very reliable motor, and not too dissimilar to the sort of motor you get to power a watch, in that it has a sort of clockwork mechanism. It isn't just like a DC motor that rotates. But then they put it through a reduction gear here, as you can see, mainly because A, to lower the speed, and B, to increase the torque, because turning this does require a bit of effort. It's even turning it with your hands, you have to put your effort. You have to really push it. So for a motor, like a simple DC motor, wouldn't be able to, or a simple cheap motor like that wouldn't be able to handle it by itself. Pardon me, the kids kept me awake last night. Let's see, how am I going to get into this, the actual cam? Just out of curiosity. I wonder if... This is probably a very bad idea, but let's give it a go. It might be, I don't know if this is 240 volts or 12 volts, but let's give it a try. No, it's not working. I think I wrecked that somewhere along the lines, or it's 240 volts. Might revisit this in another video. Okay, let's get into this bad boy. Yeah, there is a city in Northern Ireland, which I'm not going to say because I shouldn't really know this, but I know people who work for the council, and they've got those plaza water fountains, the ones that are built into the pavement, and in sunny, they turn on in sunny days for the benefits of children to jump in and frolic about and have fun, or to annoy their parents as they get wet. Here we go. It's a well, there you go. I got it all wrong. It's not a cam timer. Oh dear. Egg is very much in the vicinity of my face. This is just an encoder. It's a complicated encoder, but it's an encoder. As you turn it, effectively you change your resistance, and that's how the circuitry here knows which ones you want to, which sort of cycle you want, which must be programmed into the EEPROM. I feel like a dum-dum now. So really this is just, you know, this in a modern washing machine would this big knob would still exist that you select your cycle, but it wouldn't turn. It would there'd be no feedback. You'd have some sort of digital readout for feedback. This is mechanical feedback. So as you turn it, that adjusts. Is that right? Yeah, resistance. So that's how it detects how far on in the cycle you want, and then once the cycle starts, it turns it through this 72311 chip. Primitive, basic. Oh, I'm really disappointed now. I thought this was a cam timer, because I've taken cam timers apart before. I did think it was a bit small for a cam timer. Yes, there you go. It is all electronic operation, simple electronic operation, but still modern. Like I probably, like I'm not seeing any reprogramming pads or pins on this, whereas I'm sure of modern ones you probably would have somewhere on the board pads to allow for an engineer to upload new firmware onto the chip. But then again, this isn't really firmware, so this is a timer, so it's kind of like as I said earlier, if there's a positive voltage on a certain pin, that will trigger a timer, and when that timer completes, a voltage will go out on another pin or pins, and it basically resets itself to start state, and so on. But yeah, as I was saying about the water jets, there is a city in over there, and they had these water jets installed about 10 years ago, but they actually use a cam timer for controlling the water pumps, and they actually have the cams are actually sloped, so instead of being a drop off like that there, they're more like that, and as the contact goes over it, it changes the speed of the water pump. And they actually these are the cams that this system uses are good quality. I think they're Kevlar based, and what they can actually do is switch out different cams for different years. So in the summer, when the kids are out running around screaming and they want lots of water, they can put in a summer cam that just basically keeps the jets running all the time. But there's also an autumn cam for when you want a little bit of water but not too high. You want the pumps to run so that the water comes out maybe a foot or two. And then there's a winter set cam, which is basically puts the pumps into trickle mode so that there's a water trickling out, and that's purely to stop water freezing in the winter and damaging the system. So it's quite annoying. This is something that's still in use. Like I say, it's Roman technology, but I've got this all wrong. This isn't a cam timer. It's electronic. I'm a dum-dum. Take care. Bye-bye.